video, let us see how to override methods automatically in IntelliJ IDEA. So for this purpose, I am going to create a code in a fresh project, and let's call the class as expr node, right? And let's make it as an abstract class and call the method as void gencode, right? Now you can make the you can create the derived classes for this. Do alt enter on the expr node and implement abstract class. So you need to give the name of the class. Let's call it as add expr node and in the same package. So which methods to override? Yes, of course, the gencode method. And here what we're going to do is we're going to add two fields. The expression node, let's say it's a binary expression, so we have left and right. So the expression node left and right. Now let's create the constructor for this and use these two fields to get initialized. And now in the gencode method, what we are going to do is we are going to call left dot gencode and right dot gencode, and then we have I add as a bytecode to get printed, let's say, and we print it to the console. Alright, now let's come back to the previous main class and let's get another derived class of expr node. This time we call it as mult expr node in the same destination package. Override the gencode method, and in this we are going to say two fields the same way as the add node, and say expression node left and right, and generate the constructor with these two fields and call left dot gencode and right dot gencode, and imul is the bytecode that we can use, and here it is. So we have implemented the two derived classes of expr node, both binary expression node, add and multiply. Now let's create a main class. So let's call it as main and create a public method, a public static void main method, and in this let's create a quick expression tree. Let's call it as 10 star 20 plus 30. So let's create the expression tree corresponding to that. Expression node tree equal to, so first we have to get the expression node for the left into left plus 30, right? So we need the constant node for this, so let's implement an abstract called constant and implement the gencode method. And when it comes to the constant, we have let's say it's integer expression, so let's say we have integer val and initialize it with the constructor. And in the gencode we say iload plus val, and we need to make this printed, and here we go. Let's come back here and create this expression. So first one is the left tree plus, so new add expression node, and the left comma the right will be the constant, so new constant of value 30. Now this is the right node, the left of that will be a new mult node, and the left of that and the right of that, so the left of that will be new constant of 10 and new constant of 20, right? So let's automatically improve this code and see if this is completed. Yeah, so now let's do tree dot gencode and see if this program runs. Yes, iload 10, iload 20, imul, iload 30, and I add. So in this short video we have seen how to create the derived classes of EXPR node. For example, if you want to create an derived class of that implements the abstract class, let's say div node. So we can create it like this instead of creating it from scratch and provide the methods. So expression node, left comma right, and then instead of typing the constructor from scratch, you can generate the constructor by providing the fields that is to be initialized in the constructor. And now left dot gencode, right dot gencode, and then I mod, no, this is div, right? I div dot yes out. So yeah, this is how we can implement an abstract class by alt enter. Do an alt enter and you can create a subclass or implement the class. So give it a try.